Hello and welcome back to the CCNA video series brought to you by ABY Design and Tech. In this video, we're going to take everything that we've learned about subnetting and now apply this to some typical questions that you may see in the CCNA exam. So I'm not going to ramble on any further, let's just dive straight in. So, typical subnet question 1. The design requires 200 subnets and 120 hosts per subnet. A single mask is used and it must allow for 20% growth. Which answer meets those requirements? Pause the video and try this yourself. When you think you've got the answer, play it and I will explain it to you. So, I'm assuming that you've had a chance to pause the video. And this assumption has led me to the fact that I'm going to now work through this question. And I want you guys to watch me because you can learn a lot just by watching how somebody tackles a question and see the exact thought process behind this. So, reading through this question, I know that in order to answer this question, I need to work out the actual requirements for this. So, 200 hosts, 200 subnets, 120 hosts per subnet, okay, 20% growth. So these are three important facts that I've highlighted in this question. So this question is kind of a trick question because here is listing 120 hosts per subnet. However, in reality, we need to support more hosts per subnet because we have to allow for 20% growth. So I'm going to calculate how many hosts per subnet we would have after that 20% growth has taken place. So 120, 20% of that is going to be 24, which leaves me was 144. So I will need to make room for 144 hosts per subnet. So let me just rub out the 120 so that it doesn't confuse me because I may get the answer wrong then. So now I need to work out how many host bits I need and how many subnet bits I need. So right off the bat, I know that I would need a host bits and a subnet bits to meet my requirements. 7 bits gives me 128, which does not meet my requirements after this growth has taken place. Before the growth has taken place, yeah, that would have met my requirements, but it wouldn't allow for 20% growth. So that means, by process of elimination, that 7 bits is not valid, 8 bits is valid. So I need to have at least 8 host bits and at least 8 subnet bits after subnetting to meet the requirements. Now, that rules out number 4 completely. The reason being, number 4 is Class C network. There's only a single network. There's no subnetting going on over here. So that rules that one out. It also rules out number 3. The reason being, number 3, that uses a /16 subnet mask by default. So a Class B network is a /16 subnet mask. /23, that means I've only got 7 subnet bits with 9 host bits. So I meet the host requirements, but I don't meet the subnet requirements, ruling that one out. Number 1 is also ruled out because that only allows for me to have 7 host bits, which again does not meet my requirements of having 8 host bits. So from process of elimination, number 2 is the correct answer because that gives me enough subnet bits and enough host bits to meet my requirements. Now on to question 2. The design uses Class A network 10000. We must use a single mask and requirements are 1000 subnets and 200 hosts per subnet. Which mask meets the requirements and maximizes the number of subnets? So pause the video, try this yourself, and then when you think you've got the answer, play it and we will work through this together. So I'm assuming you paused the video, so I'm going to dive straight in. The way that I would tackle this particular question would again be to look at the question and work out what they're actually asking from me. So I know my requirements, 1000 subnets, 200 hosts per subnet, and it says here, which mask meets the requirements and maximizes the number of subnets. Now when I see this is what I think. I need to use the largest subnet mask I can while still allowing for the number of hosts per subnet. So what does that mean, Abda? So it asks for 200 hosts per subnet. I know that I would need to have at least 8, at a very minimum, 8 host bits to meet that requirement. I also know that a subnet mask is made up of 32 binary bits. So 32 minus 8 gives me 24. So my answer is number 4 /24. The reason being, is because a /24, that is the largest subnet mask I can have, while still allowing for 8 host bits. I can't have a subnet mask larger than that, because then otherwise I won't be meeting the requirement of 200 hosts per subnet. So number 4 is the correct answer. These other ones, 1, 2, and 3, they're also correct, but they don't maximize the number of subnet bits that we have. Again, a /24, that allows me to maximize the number of subnet bits I have, while still meeting the requirements of 200 hosts per subnet, meaning number 4 is the right answer. So moving on to question 3. Which of the following is not a valid subnet ID for network 10.0.0.0 using a /25 mask? Pause the video, try this yourself, and then we'll dive in together. So I'm assuming you've paused the video and you've given this a good old-fashioned try. So now I'm going to work through this myself. So looking at this question, it's saying which of the following is not a valid subnet ID for network 10.0.0.0 using a /25 mask. The first thing I would do is to work out my increment, because then that will tell me what my subnet IDs should be and which octet I should be incrementing in to find my next subnet ID. So taking that into account, a /25 mask, that's 25 binary ones, so you've got 8 binary ones followed by 8 binary ones followed by 8 binary ones, and then in the 4th octet we have 1 binary 1 followed by 7 binary zeros. So I'm going to write that number in my subnetting chart down here. So imagine these are all zeros, etc. And then to find my increment, I look at where the last binary 1 is, line that up with the column. That means that my increment is going to be 128 in the last octet. So now, in the last octet, with a 128 increment, I can either have 0 or 128 in the last octet. Now looking at all these answers over here, number 4 is the right answer. The reason being is because I can either have a 0 or 128 in the last octet. 1, 2, and 3, those all show valid subnet IDs because there's either a 0 or there's either a 128 in the last octet. Number 4 shows a 192 in the last octet, meaning it cannot possibly be a valid subnet ID, which rules this out straight away. So number 4 is the right answer. Moving on to number 5. You are assigned address range 10.188.31.0/23. You are asked to develop a subnet plan to allow the maximum number of subnets with as many as 30 hosts each. Okay guys, so pause the video, give this a try yourself, and then when you think you've got the answer, play it and we'll work through this together. So I'm under the assumption that you've given this a try, so now I am going to work through this. So looking at this question, I can see that we're not using a typical class A, B or C network. We're actually given a subnet and then we're asking to subnet this down even further. Now, taking that into account, it's saying that we want to allow for the maximum number of subnets while still meeting our requirements of 30 hosts each. So to work out this question, I need to work out how many host bits I need at a minimum to meet the requirements of 30 hosts per subnet. So 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32. 32 minus 2 is 30. So 5 subnet bits meets my requirements. And then to find out what is the largest subnet mask I can have, I literally just do 32 minus 5, which gives me a /27. So a /27 is the largest subnet mask I can have, which meets my requirements of at least 30 hosts per subnet, and also maximizes the number of subnets because it gives me the most subnet bits. That means that number 1 is the correct answer, is the right answer. Now, number 2 and number 5, they also allow for 30 hosts per subnet, but they don't maximize the number of subnet bits we have. Because if we were to subnet down to a /25, we've got 2 subnet bits. Answer 2 provides me with 3 subnet bits. Number 1 gives me 4 subnet bits. So again, that's maximizing the number of subnet bits I have, which meets the requirements and answers the question. Question 5, and this is the last question. You've been asked to configure 113 point-to-point links. Which IP addressing scheme and subnet mask meets the requirements and wastes fewest subnet and host addresses? So pause this, give it a go, and then play it when you think you've got the answer. So again, I am under the assumption that you have given this a try. So me working through this, let me look at the question. So over here, let me get my pen. This statement here tells me everything I need to know regarding the requirements. So it tells me 113 point-to-point links. All a point-to-point link is, it's just a single link between two routers usually. So that's what a point-to-point link is going to be. And for a point-to-point link, we only need to have two IP addresses. So one for either router on either end of the point-to-point link. And so we need 113 subnets because we are going to have 113 point-to-point links. Each point-to-point link is its own network segment. And because it's going to be point-to-point, we need to have two usable IP addresses per subnet. So now I've got my requirements. Let me work out how many host bits and how many subnet bits I need. So to meet the subnet requirements, I need to have 7 subnet bits. To meet the host requirements, I need to have 2 subnet bits. The reason being is because to work out how many usable IP addresses we need, we always do 2 to the power of -2. So in this case, 2 to the power of 2 is 4, -2 gives me 2. So I need to have 2 host bits and 7 subnet bits. Now it says here, we need to waste as few subnet and host addresses as possible, which means that the subnet mask I need to choose needs to have, strictly speaking, only 7 subnet bits and only 2 host bits, because only that way am I going to waste a few addresses and subnets as possible, or as close to those requirements. Now, every answer 1, 2, 3, and 4 gives me the same subnet mask. That's 255, 255, 255, 252. Now I know that's going to be 24 binary ones followed by how many binary ones? So 252, we need to convert this from decimal into binary. Now, luckily for us, we know that subnet masks are going to be a set of ones followed by a set of zeros. So to convert this, all I do is go through my chart, keep listing ones until I make 252. So 128, 192, 224, 240, 248, 252. That is 1, 2, 3, 4, 5, 6. 6 plus 24, that is 30 bits. So this is a /30 subnet mask. Now, I know that I need to have 7 subnet bits. So /30 minus 7 gives me 23. So I need to begin with a /23 subnet mask before I subnet that down to a /30 to waste as few subnets and few host addresses as possible, because that is only going to allow me for 7 subnet bits and 2 host bits. Now, out of all the answers over here, number 4 is going to be the right answer. With number 4, we start with a /23. We then subnet that down further to a /30, which means we need to have 7 subnet bits. And a /30 still leaves us with 2 host bits. That meets our requirements. Now, it's important to note that all these other ones meet our requirements as well. But this is why it's important to read the question properly, because it's saying we need to waste a few subnets and host addresses as possible. Now, the one which allows strictly for 7 subnet bits and 2 host bits is number 4, because number 4 we begin with a /23. To get to a /30, we have to take 7 host bits, so we're left with 7 subnet bits, 2 host bits, and that meets our requirements. So, we have reached the end of this video, and just to recap, all we've done is that we've just gone through a series of questions which are similar to the questions which you may encounter in the CCNA exam. Now, these questions, they're not going to be the exact questions that you're going to encounter, because again, that's going to be cheating, and nobody wants to be a cheater. However, what I want you guys to take away from this is that to answer the questions, you don't have to go through the entire process. You only have to go through parts of the subnetting process to actually get what you need to answer the question. And so I hope that by going through these questions, you've seen ways to actually approach the questions themselves and some kind of shortcuts that you can use to get to your answer quickly. In the next video, we're going to be focusing on variable and subnet masking and the process behind that. If you have enjoyed this video and you would like to see more content like this, then please subscribe to my channel, and thank you very much for watching.